parallel lines and proportional parts. Alright, theorem 7.5 on page 490. If a line, this is important, if a line is parallel to one side of a triangle, and intersects the other two sides, then it divides the sides into segments of proportional lengths. If a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. So here's a picture of that. So you got a triangle. Alright, if a line is parallel to one side of a triangle, so if we add a parallel line right here, and then put the symbol on there that says it's parallel, the red arrow, and call this triangle around the outside ACD, and this parallel line is BE. Okay, so here's the rule. If a line is parallel to one side of a triangle and intersects the other two sides, BE is parallel to CD and it intersects these two sides. Then it divides the sides into segments of proportional lengths. What that means is that there's a couple ways you can write this, but it means that AB, segment AB, over segment BC. Alright? This left segment over this right segment. Proportional lengths. Remember, a proportion is an equation showing two ratios equal. So AB over BC is going to be equal to AE over ED. That proportion will be true. Got it? That's if a line is parallel to one side of a triangle and it intersects the other two sides, then these pieces or segments will be proportional. So if let's say that A to B is 7.5 and B to C is 3. AE, and let's make this 2.5. E to D is 2.5. Alright? And you're asked to find AE. Okay? So you can keep AE as a variable, or you can call it the letter X. And then you can just use this template to set up your proportion. So you would make 7.5 over 3 equal to X over 2.5. And we did that all last week. So if you crisscross multiply, crisscross products are true in a proportion. So you've got 3 times X is 3X equal to 7.5 times 2.5. That's 18.75. And then you could divide both sides by 3. And your X would be equal to 6.25. So this piece right here is equal to 6.25. Everybody all right with that? Anybody confused? All right, the converse of that theorem is on the page of 491. You want to get that in your notes. It says that if a line intersects two sides of a triangle, if a line intersects two sides of a triangle, if a line intersects two sides of a triangle and separates the sides into proportional segments, then the line is parallel to the third side. And let's see, let's take a look at the examples on page 491. Example number 2. They give you this triangle. D, E, F, G, H. Alright, we're going to use the same triangle for 2 scenarios here. Example 2 says, in triangle DEF, EH equals 3, HF equals 9. Okay? Then it says, and DG is 1/3 of GF. Okay, so D to G is 1/3 of G to F. The question is DE parallel to GH? Okay? D to G is 1/3 of G to F. So is E to H 1/3 of HF? I'll ask you again. Is E to H 1/3 of H to F? 3 is 1/3 of 9, right? If they tell you that DG is 1/3 of GF, are the two segments parallel? Yes, they are. Because look, if you wanted to try to make it true mathematically, if DG is 1/3 of GF, you could call GF whatever you want. Call it 3. And what's 1/3 of 3? 1. Right? So now you can write a proportion and see if it's true. Is 1 over 3 equal to 3 over 9? 1 times 9 is 9. 3 times 3 is 3. 3 times 3 is 9. And 9 equals 9. So crisscross products are equal to each other. So it's proportional. So yes, they're parallel. Got it? That's one type of question, or one type of answer. And then if you look at the guided practice, in that same box there, here's an example of when it's not parallel. It says now that DG is half the length of, so let's change these for a second. D to G is half the length of G to F. E to H is 6. H to F is 10. Alright, now it says that D to G is half of G to F. So if G to F is 8, D to G is half of that. So let's make it 4. So now, does 4 over 8 equal 6 over 10? Four times 10 is 40. 8 times 6 is 48. These two are not equal. So in that case, DE is not parallel to GH. Alright, so there's an example of parallel, and there's an example of not parallel. Thank you. Alright, bottom of that page, mid-segment. A mid-segment of a triangle is the segment with endpoints that are midpoints of the two sides, or of two sides of a triangle. A mid-segment of a triangle is a segment with endpoints that are midpoints of two sides of a triangle. So if you take a triangle and you identify the midpoints of two sides, so right here I'm going to call this point the middle of AB, we'll call it D. And then the middle of BC might be around here. Call that E. Now, here's what it looks like. If E is the midpoint of BC, it's in the middle, so these segments are congruent. And if D is in the middle of AB, then AD and DB are congruent. Now, a midsegment of a triangle is a segment with endpoints that are midpoints of two sides. So if we connect D and E, okay, that is called a midsegment. Right here, this is called a midsegment. Here's the rule about a mid-segment. The mid-segment of a triangle is parallel to one side and 1/2 its length. So if a segment connects two midpoints, then it's called a midsegment. If it's a midsegment, it's parallel to one of the sides, which in this case is AC, and it is half of its length. Okay, so if AC is 20, then DE is 10. Mid-segments, parallel to a side and half of its length. As a formula, if you need to, you can say that DE equals 1/2 AC. DE equals 1/2 AC. Alright? You can also say that 2 times DE. 2 times DE is equal to AC. Because some of the times you're going to be given the length of the midsegment and asked to find the third side. Sometimes you'll be given the side of the triangle and asked to find the midsegment. So you can use either of these formulas. Midsegment equals half the side of the triangle, or 2 times the midsegment equals the third side of the triangle. Questions? One more rule on the bottom of page 492. Bottom of page 492. If 3 or more parallel lines intersect two transversals, then they cut off the transversals proportionately. Then they cut the transversals proportionally. So a picture of that would look like if 3 or more parallel lines. So here, let's take 1, 2, 3 parallel lines, and you would know they are parallel if they've got the red arrows on them. 3 or more parallel lines intersect two transversals. So here's one transversal and here's another transversal. So we got a true statement so forth. Then they cut the transversals proportionally. So if this is A, B, and C, and over on the right points D, E, and F, then just like in that triangle earlier, if these 3 horizontal lines are parallel and they're cut by two transversals, then AB over BC will be equal to DE over EF. That proportion will be true. And if you're given different lengths along these transversals, then you can find the missing piece. Alright, if this is 3 and this is 18, and this is X, and this is, I don't know what this is, we'll call it 21. Okay, and you're asked to find the missing piece, the length of the missing piece. You would take 3 over 18 and make it equal to X over 21. Crisscross multiply, so 18x would equal 63, and then you could divide by 18. And your x would equal 63 divided by 18. 3.5. Anybody confused or have any questions? About parallel lines and proportional parts? Okay, your practice for today